partial fractions. Right, at GCSE, you had this style of question, okay, where it might have said express this as a single fraction. Here you can see you've got two separate fractions. You're looking at the difference of them, and you have to express it as a single fraction. So you go through the algebraic process of this, okay, and you ended up with this solution, okay. So you've got a single fraction here. Now I'm not going to show you how to do that, okay, because that was what you did at GCSE. However, at A level, okay, you get this style of question, okay. So it says here, express this single fraction here in terms of partial fractions. So in effect, it's the reverse process, okay. So they give you this and they want you to get back to the single fractions we've got here, okay. And that's why this sort of topic is called partial fractions, because if you think about the word partial, it comes from the word part, okay, so, or parts, okay. So we want to write this into separate parts here, so we've got separate fractions here. So we're going to reverse the process. So I'm going to show you now how to do that, okay. So there you go, typical exam question here then, okay. So here we've got the question that we just looked at, okay, and we're going to see if we can reverse this now to get to the original question, the GCSE style question. So what you do is, right, you first of all write the single fraction here that we've got here into parts, okay. We split it into parts so that you've got two parts in this case, where the denominator, okay, so you have two parts. The denominator, first denominator will be this bracket here, and the second denominator will be this bracket here. Now, we don't know, okay, when we have these questions, we don't know what numbers go on the top here, what numbers go in the numerator. So we're going to call this A, and we can call this B, and we're going to put a plus there. Now, it could work out to be negative, okay. We don't know that, but we'll just put them as both positive to start with, okay. So we've got ourselves set up here an equation, and we're actually going to work out now what A is and what B is. And we do that quite simply by appreciating here that we've got x plus 7 divide all of this, okay. So we're dividing by all of this. Now if I take it over the other side, think about what I'd be doing. So in other words, I just want to leave x plus 7 here, okay, and I'm going to take all of this here that I'm dividing by over the other side, and I'm going to multiply. So I'll have x minus 2, x plus 1, and so I'm taking it over and I'm going to multiply by all of this. So I multiply all of this by this here. I need to put maybe a square bracket, okay. So I have x minus 2 there, plus b, x plus 1 there. Okay, so simple algebra, all I've done is I've taken this, as I said, over to the side, multiply. So I'm going to multiply through, so I have x plus 7. If I multiply through the first term, so I have a over x minus 2, multiply by x minus 2, x plus 1, plus then the second term here, b, over x plus 1, multiply then by all of this here. Okay, what happens then is that these terms will cancel. So the x minus 2 here cancels with this x minus 2 here, okay, because you've got this on top, this on bottom, so they cancel each other out. The x plus 1 here will cancel with that x plus 1, and you're left with x plus 7 equals to a, bracket x plus 1, okay, and then plus b, bracket then x minus 2, okay. So you're left with that there. So we've got a single line here which we can work with. Now I want to work out what a and b are, okay. If I can work out what a and b are, I've solved the problem, okay, and I've got my answer. In order to work out a and b, I now need to set x to be a certain value, okay. Now we can be clever here in terms of the values that we set x to be. So for instance, if I set x to equal 2, okay, set x to be 2 will really help us, because when I put 2 in here, I'll have 2 plus 7, okay, which obviously is 9. I put 2 in there, 2 plus 1, but put 2 in here, notice what happens, this will become 0, okay. So I'll have b times 0. So that's why I set x to be 2, because by setting x to be 2, this becomes 0, and b times 0 will be 0, it disappears. So I'll end up having 9 here equals to 3a, and that means then I've got a to be Well, 9 is 3a, take the 3 over and divide, so I get 3. Okay, so a is 3, we sorted. To work out b, okay, I need to set x to be a different value, but think about what I've got here, go back to this, and think about being clever to sort of eliminate this time the a. So what can I set x to be here to eliminate the a? Well, if I go the opposite of this and set x to be negative 1, okay, chuck it in, I've got negative 1, add 7, negative 1 in there, plus 1 is 0, so that goes, and then I've got here, okay, negative 1, negative 2, so you've got 6 here, and you've got negative 3b here. That means then b will equal to 6 divided by minus 3, so you get negative 2. There's my answer. So I've got an answer for A, I've got an answer for B. What I do then is I go back to that top line then and substitute them in. Okay, so you know we could write this out again, right, which is what I expect you to do at the bottom, but I'll write them up here so it's sort of clear, you can see the connection with it. So A is 3, now B is minus 2, okay, negative 2. So I'm not going to write minus 2 on top there. I'm going to put the minus in front and put the 2 here, okay? So I end up with that. And if I go back to the original statement I talked about earlier, you can see it's those single fractions that are exactly the same. So by reversing the process, so obviously a long method, but you can reverse the process, and we put them into partial fractions.